Okay, guys, this is 1.7, I believe. I want to go over this really quick. Here they say solve equations involving absolute value and solve inequalities involving absolute value. So it's very easy. It's not a big deal. When you see this, usually in an absolute value inequality, that means that this will be an and. And if you see this, that means that that will be an or. Okay, I will explain to you by example, so then after that you will be able to understand easily. Okay, so this is for the equations, right? Okay, so you can just remember this rule: if a is greater than 0 and u is an algebraic expression, then the absolute value of u is a, is equivalent to say u equals to a and or u equals negative a, and the absolute value of u equals negative a has no solutions when a is greater than 0. Okay, so here they give you an example, right? So this is pretty straightforward. Anything you need to do is, well, in this case, I will have to do x plus 3 equals to 0, right? I should put positive and negative here, right? But because 0 doesn't have a sign, right? And because of this rule here, they said that a has to be greater than 0, right? For me to put the negative, right? But in this case, you can just say x plus 3 equals to 0. So you solve for negative. You solve for x in both sides and you get negative 3 here, right? Here the same thing. So this is going to be 2x minus 3. Now, because this is going to be 13 now, you need to write it in that standard form, ax plus b equals c, right? Once you write it in that form, then you can do the positive and negative on the c, right? So that's going to be 2x minus 3 equals 13, and then 2x minus 3 equals negative 13. So now you solve, right? So this is 2x, 16, x equals to 8, and then you have 2x, add 3 on both sides, you get 10, x equals 5, right? You should be able to know how to do that, right? For the first one, of course, we just have one solution. For the second one, you should have 2, right? Which is 5 and 8. Yeah, here I missed the sign. 85 and 8, sorry. Okay. So sometimes you might have problems like this one, right? That's not a big deal. The only thing you need to do is, the way I see it is, when you have this situation, you can just write it as it is without the absolute value. Okay, that's one. And then for the other one, just change the sign either of this or this. What do I mean by that? I mean, if I'm working with the left absolute value, I can just say, well, this is going to be negative x plus 1 equals x plus 5. So I just change either the left side or the right side, so you will get the same anyway. So here this cancels out, right? X minus x cancel out. So this is negative 1 equals 5. This is a false statement, so that means you're not going to get a solution there. And here you can say, well, if I add x in both sides, right, I get 1 equals 2x plus 5. Subtracting negative 5 in both sides, you're going to get negative 4, 2x here, and divide by 2, you get x equals negative 2, right? So that's your solution for this problem. Okay. So here the same thing, right? This one the same thing. You do 2x minus 1 equals x plus 5, and then you do the reverse or the negative version of that, which would be negative 2x plus 1 equals x plus 5, and you solve for x, right? So this is going to be x, this is 6, and then here you have negative 3x, and then this is going to be 4, so x should be 4 over 3, and it's going to be negative, right? So that's how they did it. Okay. Now this is what I want you to remember: the rules for solving absolute value inequalities, right? They say that if a is greater than 0 and u is an algebraic expression, then absolute value of u is less than a is equivalent to negative a less than u less than a. If u is less or equal than a is equivalent to negative a, less or equal than u less or equal than a, and if absolute value of u is greater than a, is equivalent to u is less than negative a, or u is greater than a. Absolute value of u is greater or equal than a is equivalent to u less than negative a, or u greater or equal than a, right? So you can try this one if you want. So the first thing you should be able to identify if this is an or and, right? So this is a and, right? So you can just say 4x minus 1 equals less or equal than negative 9, I'm sorry, and then 4x minus 1, you change the inequality and you change the sign of the number. Now you solve. So this is plus 1, this is going to be 4x less or equal than 10, you divide by 4, and you get x less or equal than 5 halves. Then for the other one, you add 1 in both sides, then this cancels out. 4x is negative 8, and divide by 4, you get negative 2, right? Now, because this is an and situation, we're looking for the overlap, right? So this is negative 2, and this is going to be 5 halves, right? So both close because they have this part here, they have this thing here. So when they're less or equal or greater than equal, that means that that's included, and that's supposed to be your graph. So if your order pair should be negative 2 to 5 halves, that's your final answer for this problem, right? And they put it in that interval notation, right? Which is the same as I have, right? Okay. Okay. Now I have a lot of problems just to practice, right? So the main idea with the and or, you can think about this. Look, if you have the absolute value of a is less than, let's say, let's put a number like 5, right? So that means that you can think about absolute value as the distance from 0, right? So if you think about 0, negative 5, and 5, well, what I'm saying here is that since this 5 is not included, so we not include this 5, any value that you put between this range is gonna give you the answer, or it's gonna be a true statement. For example, if you plug negative 4, that's gonna be 4, right? Because absolute value of negative 4 is 4, and 4 is less than 5. So that's the idea, right? Negative 4, you can put negative 3, negative 2, negative 1, 0, 1, 2. But if you put 5, that's not going to work, right? Because 5 is not less than 5. Or if you put negative 5, the absolute value of negative 5 is positive 5, and 5 is not less than 5. So that's the idea behind this thing, right? That's the idea behind this thing. That's the reason that this statement, it is like that. Now, if this was like this, then you should include this, right? But again, it's the intersection, right, between these two. So that's what they are looking for. Okay, so this is an and statement, right? Okay, so let's solve the problems. And if this is an and statement, let me go back. If this is an and statement, then the other one should be an or statement, right? And or means union, right? Union or you, and this is and, you will see like intersection like that, right? Okay, so let's solve the problem, so that will make more sense. So here they have the absolute value of 6n, right? So the only thing you need to do is 6n. You basically copy the same thing, and then you do the reverse. You change the inequality and you put negative 18, and you solve for this, right? You divide by 6, and it's going to be less or equal than 3, and then you do divide by 6 here, and it's going to be greater or equal than negative 3. So you put negative 3 here. Remember, this is closed, right? This is included. So this is negative 3 here, and then you have 3 here, and you want the intersection between these two. So that's the answer. So as an interval notation, you can write negative 3, I'm sorry, included, right? Negative 3, comma, 3, both included. So that's the answer for that one, right? let's do maybe 2 or 3, doesn't matter, they're almost the same. So p plus 4, you basically, this again, you need to be able to recognize that this is an end statement, right? And this is what, less than 8, and then the other one is p plus 4. Remember, this is end, right? P plus 4 is change the inequality and change the sign of the number. So this is going to be p, subtract -4 in both sides, you get 4, and then subtract -4 in both sides, you get -12. So you know that this is end statement, right? So you go to -12, and then you go to 4, and you know that this is the intersection between these two. So that's your answer. As an inequality note, in the interval notation, you would put -12, that's included, and then 4 is also included. So that's the answer, right? Let's do another one that is kind of unusual. Let's do this one. For this one, the strategy kind of the same, but not exactly. Now, the first thing you should be able to recognize that this is what? An OR statement. This is not AND, this is OR, right? And the strategy is you put the absolute value, the negative version of that, but let's put the positive version first. So this is going to be x plus 5, 11, or, right, negative x plus 5, 11, right? So this is going to be -5 in both sides, x greater or equal than 6, union, right? Because OR is union, -5 in both sides, negative x, less or equal than 6, right? And I need to divide, let me fix that. So -5, we said, right? So that's going to be negative x greater or equal than 6. Now you divide by 81 both sides, or multiply by 81 both sides, right? So this cancels, so you get x. When you divide it in the inequality by a negative number, the inequality change, right? In direction. So this is why you have -6. This is your solution, right? So -6 is here. And when numbers are less than 86, you can think about 87, right? 88, 89, 10, and so on, right? So that means that this goes to the left side. And then 6 is also included, and it goes, what numbers are greater than 6? 7, 8, 9, 10, 11, 12 till infinity, right? So you go that direction. So that's what you're supposed to have. Now you can check if you don't believe me. You put -6 here, right? -6, absolute value of -6 is what? 6. 6 plus 5 is 11. Is 11 greater or equal than 11? Yes. You put another number, -8. -8. Absolute value of -8 is what? 8. 8 plus 5 is 13. Is 13 greater or equal than 11? Of course. Now you go to the other side. 6. 6 plus 11. I'm sorry, absolute value of 6 is 6 plus 5 is 11. Is 11 greater or equal than 11? Yes. You put next number, 10. Absolute value of 10 is 10. Plus 5, 15. Is 15 greater or equal than 11? Yes. Now, you can check. You see that region that there's like a gap. There's like we didn't put those values. Let's check if that's true. If you put -4, right? Absolute value of -4 is 4. 4 plus 5, it's 9. Is 9 greater or equal than 11? No. Try another number, 0. The absolute value of 0 is 0. 0 plus 5, 5. Is 5 greater or equal than 11? No. You check with the other number, 4. The absolute value of 4 is 4. 4 plus 5, 9. Is 9 greater or equal than 11? No. So now you know that you're doing the right thing. So this is the answer, right? This is the answer. Okay. Here you have to add 2 in both sides, right? You need to add 2 in both sides here. And then you set one negative and one positive, right? So you can say this is m equals 2, right? And then you can do m negative m if you want. Yeah, and then you can just flip the inequality, right? So that's going to be -2. Now you put -2 here. That's not included, so we don't need to include, and the 2 we don't need to include. So we're saying that this is union, right? Should be both directions. So now let's check. If if you see the 2's are not included, right? So you have to put -3. So absolute value of -3 is 3. 3 minus 2 is 1. So that works. And all the numbers to the right, they're gonna work. To the left, they're gonna work. The same thing applies for the right side, right? You put 3. Absolute value of 3 is 3 minus 2 is 1. So 1 is greater than 0. Now, the overlap, if you put -2 here, that's not gonna be true, right? Because absolute value of -2 is 2. 2 minus 2 is not greater than 0. So that's not true. If you put 0, that's gonna be -2. Is -2 greater than 0? No, right? Okay, so that's the idea. Okay, I'm not gonna do all of them because I don't want to bore you. I'm just gonna do the ones that might be a little tricky. Okay, let's see. Like this one. This one, you don't even need to do anything because you know that the absolute value of whatever is inside the absolute value is going to be greater 0 or greater than, it's going to be 0 or positive numbers, right? So you know that this is going to be all real numbers because any number comes out from absolute value is going to be 0 or positive numbers. So that's going to be anyway greater than -11. So the answer here is -infinity, infinity. I don't need to do nothing, right? You can just, if you want to, you can do like everything, like you can do like this if you want, right? It goes forever, right? So be careful with this problem, right? Okay. Let me see if there's another one tricky here. Like this one, right? I think let me see. Yeah, let's try this one. So here I need to write it in that form, right? AX plus B or equals greater than C or vice versa, right? Like this, right? So you have to solve for this one, right? So here I have 9 absolute value of R minus 2. If I add 10 in both sides, I get -63, right? And if you divide by 9, you get absolute value of R minus 2 is less than -7. Now you are ask yourself this question: is this even possible to do? No, it's not possible because whatever comes from the absolute value is what? 0 or positive. And if it's 0 or positive, how it's going to be less than -7, right? So here you can say this is an empty set, right? Or no solution, right? Because this is not possible, right? How can I do that? Okay, so that's the idea of these things. Okay, let's do one normal so you can practice, right? Like this one. Okay, so here I have 6b plus 7. I'm gonna subtract -7 in both sides. I'm gonna get 53, right? Now you do 6b plus 7 less or equal than 53, and then you do the reverse, 6 plus 7, change the inequality and change the sign of the number, right? So you solve 87, and first make sure that you identify that is union or intersection. So in this case, this is an end statement, right? So this is going to be intersection. So if you do that, this is 6b equals what? This is 46, right? Yeah, that should be 46. And then you divide by 6, right? Whatever that is. This 23 over 3, right? Yeah. And then the other one should be what? The same thing, right? Just solve for the number, right? So this is 6b, subtract 97 on both sides, you're going to get 60. And then divide by 6, you get -10, right? So -10 is here. -10 should be here. And then the other one should be 23 over 3. So you can write this as a mixed number if you want. So that's going to be what? 7, 3 over 2, right? So that's 7.66. So that's about here, right? Since this is intersection, right? You just put them together like this. Don't forget to include these values. I put equal. This is not true. This is less, right? Less or equal. And here is less or equal. Okay. So since these are included, then you you color it, right? And then that's your answer, right? Okay. And sometimes, so we cover the situation that you might get all real numbers, we cover the situation that there's no solution, and we cover the situation that we just solved. And sometimes you might have something like, this, right? You might have something like this. So here, sometimes you have to do a test point, they call test point, but let me show you easily how to do this. So the first thing you should do is put the absolute value, these three distributed like it was like a parenthesis. Think about like that for now. So this is going to be the absolute value of 3x minus 3, right? Okay. Now, think about this. The absolute value, whatever comes out, is going to be positive. So that means if I can replace the absolute value for square, right? I can do that. Because anyway, whatever comes out from that is going to be positive, and this is the same idea. So you can use that concept interchangeably. Now, what you need to do is expand this x squared plus 2x plus 1, and then you have 9x squared minus 18x plus 9, right? Now we set this equal to 0 to find out what's the answer, right? So here we have to do ax squared, subtracting negative x squared in both sides, subtracting negative 2x in both sides give me negative 20x, and subtracting negative 1 in both sides will give me positive a here. And now here I have 0, right? So now I can use the AC method, right? So this is x squared minus 20x, AC method, by the way. Okay, x squared minus 20x plus 64, right? So that's going to be the parentheses, right? X minus 16, x plus 4, actually x minus 4. Negative 16 times negative 4 is positive 64. Negative 16 and negative 4x, it gives you the middle term, which is negative 20x, and x times x give you x squared. Now you need to divide by 8, because remember when we do the AC method, we need to do that. So this is x minus 2, and this is going to be x minus 1/2, right? So this is 0, right? So now you do the number line, and now you need to do this point test. So if you solve for 0, this will be 1/2 here, and this will be 2, right? Now we want values greater than 0. In other words, we want positive values, right? So if you think about 1/2 and 2, what number is less than 1/2? Think about negative 5, let's say. So negative 5, if you put negative 5 in the parentheses, you're going to get negative. And if you put negative 5 here, you're going to get negative, right? Negative 7, and here you're going to get negative 5.5, right? So that's going to be positive. So this is positive. And all to make it easy for you to remember, when you have this this situation, it's always going to be positive, negative, positive, okay? So if the first one, for instance, was, let's say, the first interval was negative, then it would be negative, positive, negative, if it's linear, right? So that means that you can do this like that way. Okay, in this case, we get for the interval less than 1/2, we get negative, right? And you can check if you don't believe me. You can put 0 here, right? Because 1/2, 0 is between 1/2 and 2, right? If you put 0 here, you're gonna get negative, and here you're gonna get well, in that case, we'll get positive, right? But you can put another number, you will see it will not work, right? You can put like, you have to be careful with this, but that's a pattern, okay? So if this is positive, this will be negative, and this will be positive. If you choose 3, for example, for the right side, you will have 3 minus 2, that will be 1, right? And then you will put 3 minus 2, that will be 2.5. So positive and positive, it's a positive, okay? So here, it will be positive. So I check this, I check that. And let's see why this one that didn't work out. Let's put 1. We put 1, it's gonna be negative 1. Oh, there you go. If you put 1, here it will be negative 1, right? And if you put 1, here you have positive 1, positive 1/2. So that would be negative, right? So be careful, because when I put 0, I get negative 2, right? And then when I put 0 here, I get negative 1/2. But that doesn't mean that that's gonna work with for that interval. You have to check with another number. But to make it simple, this is always a pattern. Just check the first interval. So for example, for the 1/2, I check, let's say, -5, and that's far from the point. So that's going to be -7, right? And then if you put -5, that's going to be -5.5. So that's going to be a big number, negative and positive. I'm sorry, because negative and negative makes a positive. And then the pattern repeats, right? Positive, negative, positive. Now you want the interval, which the interval which are greater than 0. So you put -infinity to 1/2, not including 1/2 because they don't have the little thing here, right? And in this case, you have to put union, well, the other interval which is positive, right? 2 to infinity. And that's it. That's how you do that. Okay? That's how you do that. So make sure that you know how to do this. Okay, so this is the end of this video. I'm gonna try to record the whatever left over, which is the Picard rule of signs, the rational root theorem, and the polynomials, I believe, how to factor or what's left over, and the equation of the circle. And that's pretty much it. That we covered everything else. There's nothing else to cover. Okay, so we just need to do the rational root theorem, the Descartes rule of signs, the equation of the circle, and that's it. That's basically it. There's not, oh, and the behavior, the end behavior of the polynomial function, right? But everything else we cover, like in the homework, we cover synthetic division, we cover long division. You know how to solve exponential equations. So you should be fine, right? You should be fine for this test. Okay? Okay, have a nice day.